Okay, guys, this is video number 5, which I'm sorry to say corresponds with worksheet number 4. That's the green worksheet. Okay, so what we're going to be doing today is mixing all of the stoichiometry we've done so far, all the conversions, moles to grams, moles to liters, and moles to molecules, all mixed up together. If I went to lab and I asked you to measure out 4 moles of something, remember it's a made up unit. You can't do that. So what's more likely is that I would ask you to go measure the mass of something, right? Mass is measured in grams, and we can relate mass to moles, right? We've done mass to mole conversions. If we remember correctly, 1 mole equals the molar mass of any substance in grams. Or molar mass comes from the periodic table. And I can relate moles to liters or volume. Volume in liters. 1 mole equals 22.4 liters. And I can relate moles to molecules or atoms. 1 mole equals 6.02 times 10 to the 23rd power joules. So when I mix everything up, I want to think about this chart. I call it the molecule. So I can relate moles to molecules. If I'm going from here to here, I need to use this conversion factor. If I'm going from volume to moles, I use this conversion factor. If I'm going from moles to grams, I use this conversion factor. So try the front side of the green sheet. You can hit pause if you need to. Okay, now I want you to flip over to the back side. The back side of your worksheet has things going from grams to liters or grams to molecules. The way we get there is by going through the unit of moles. So you have to be careful. This is not going to be a 2-box T-chart. This would be a 1, 2, 3-box T-chart. Okay? So I want to do an example, but I have to move my paper, so beware. Okay? So the example I'm going to do is how many grams are in 4.2 times 10 to the 24th molecules of CO2, carbon dioxide. Okay? When I read a problem, I'm going to think of the same steps that we've been practicing, right? Nothing is changing that much, okay? So don't freak out. The first thing I do is draw a T-chart. Then I put my given in the T-chart, 4.2 times 10 to the 24th molecules. However, this is where it changes. I'm not going from molecules to moles and stopping. I'm going from molecules to grams, right? So let's bring this sheet back. If I'm going from molecules to grams, I have to go through moles. Okay, so let's count. This is 1, 2, 3. 1, 2, 3. That means I need 3 boxes. So this is box 1. This is box 2. This is box 3. Okay? If I'm going from molecules, I can only go from molecules to moles. Okay? I can go from molecules, but the only connecting line is going from molecules to moles. Then from moles, I can go to grams. So these are my three top boxes: molecules to moles to grams. This relates to my molecule, molecules to moles to grams. 1, 2, 3 is the same as 1, 2, 3. Okay? Once I have my units in my top boxes, my bottom boxes are easy to fill out because it's always catty corner, right? Diagonal. So if we go molecules, that means molecules has to come below. And if this is moles, then moles has to come below. Once I have my units, I can then put in numbers. If I forget what they are, come back to your molecule. Molecules to moles. What number is in front of mole? It's the number 1. So the number 1 goes in front of moles here. What number is in front of cules? 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd goes in front of molecules. Then to get my numbers for this conversion factor, right, going from moles to grams, 1 mole equals molar mass. So 1 mole is going to equal the molar mass. I have to look at the periodic table. So the molar mass of what? We have to go back to our problem. The molar mass of CO2. We look on our periodic table. Carbon weighs 12, oxygen weighs 16, and then times 2, because there's 2 in the formula, gives me 32. So 12 plus 32 gives me 44 grams. Now for the math, right? Order of operation says I can multiply and then divide, or I can divide and then multiply. I like going in a straight line across because I think that helps me. But you'll get the same answer either way. So when I type this in, I type in 4.2, remember to use the E button, 24, divided by 6.02, E, 23, right, because it's on the bottom, so I divide. And then 44 is on the top, so then I multiply by 44. And I get 306.97, blah, 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 blah. Okay? Grams as my answer. Let's do another example, just so you can get the feel of it. So let's say I ask, how many liters are in a 15-gram oxygen tank? Okay, so here's my question, right? My question always involves a given, right? So I write my T-chart. Sometimes it's helpful to go back to the molecule to know how many boxes you're going to need. So I'm starting at grams, and I want liters. So I'm starting at grams, but I want liters down here. So that's 1, 2, 3 boxes. This is 1, there's box 2, and then that can be box 3. The given always goes first, right? Nothing's changed about that. Then to know what goes in my top boxes, grams goes in my first top box. I come down here, what's in my next box? Moles. So moles goes here. And then in my last top box, where I went grams to moles, and I want volume in liters. So then liters goes in my last box. Grams has to cancel and moles has to cancel. Then I can put my numbers in. 1 mole, I have a grams here, right? Grams come from the periodic table. So oxygen is diatomic. 16 times 2 gives me 32 grams. Then I have this conversion factor, right? If I forget what it is, go back to your sheet. 1 mole equals 22.4 liters. So 1 is in front of mole, and 22.4 is in front of liters. Then I do my math, right? I'm starting with 15 as my given. 32 is on the bottom, so I divide by 32. And then 22.4 is on the top, so I multiply by 22.4. And that gives me 10.5 as my answer. Okay, now I want you to work on the back of the green sheet and turn it in when you're done.